Aloha and welcome. In this video, we're going to be talking about the application of trees. So without further ado, let's go ahead and jump into the book. The trees can be used for things that are hierarchical. One of the things that really fits to this really well is the concept of a file directory system. If you're talking about like on Linux or on Windows or anything, you have files that are arranged in your directory structures. So directory structures map to this quite easily. So you've got the concept of a root, and then under a root you have folders, directories, and files. So folder slash directory, it's going to be a place that can also contain files or nothing or more folders and more files. So let's go ahead and look at this. So we've got the files root directory is represented by just the slash on Windows, things like that. It's usually C, whatever your drive letter is, colon slash. And then in this one, we've got the root directories containing two configuration files here, text files. It's going to have two folders. So the thing to note is that these configuration files here, files are considered to be leaves. They don't have any children themselves. So directories contain additional entries. Only empty directories will be considered leaf nodes, but all files, as we just mentioned, are leaf nodes as well. So these, because they don't have children under them, they don't have any folders or files under them, these are considered leaves. And of course, all these files here are considered leaves as well. So let's go ahead and analyze one of these. So what is the depth of mountains? So depth, we count the number of edges, 1, 2, 3 to get there. So that's going to be 3. I'll let you do the rest. File system trees. So a file in a file system tree is always a leaf node. A file, that's correct. A directory is another story. So we can go ahead and click on true. That's correct. I'll let you figure out the others. Binary space partitioning. So binary space partitioning is another thing that we can do with trees. It's pretty neat. So this is applicable to gaming. So in a gaming world, you may have thousands of objects in a world. So let's say you have your big world, you have lots and lots of objects in here, but you don't want to have to render everything that's in this world at the same time because that's going to be too memory intensive and it's going to take so much memory just to render it and everything. So you don't want to have to do that. You want to be only rendering the things that are visible on the screen and within your line of sight. So how do we do something like that? Well, we use something called binary space partitioning, and that's the technique of repeatedly separating a region of space into two parts and cataloging the objects that are in that region. So a BSP tree, it's a binary tree that is going to store that information using for the binary space partitioning. So each node in your BSP tree is going to have the information about a region of space and which objects you're going to have in that region of space. So in graphics applications, BSP tree can be used to store all objects for your multidimensional world that I just mentioned. You can then figure out pretty efficiently which objects you need to render on the screen at the same time. So we're going to take a look at the participation activity here. We're going to run this. It's going to show us this is our world right here. This is our multidimensional world, our 2D world here. Only a few of these objects are going to be, it shows you an idea of a screen here. Only a few are going to be visible at any moment. So we want to avoid rendering all this other stuff that's not on there. So because if we were to do that, it would be quite time consuming and memory intensive. So the BSP tree, it's going to represent the partition space. So this is your root right here. This is the entire world and it has all the objects within it, including the geometric boundaries. So then we're going to divide this. We're going to have the left child over here, and we're going to have the right child over here. So the left child represents half the world, and the node stores information about the left half's geometric boundary and a list of all the things that are within there. Then we similarly have over here, we have the right side. So we have the right node here, and that's also going to have boundary information, a list of all the things that you're going to find in there. Then we move along, and using the screen's position within the world as a lookup, you can find all the things that you need to have displayed in that period of time, or that point in time, wherever you are. And you can also further partition it to make the tree even more useful. So moving along, binary space partitioning, when traversing down a BSP tree, half the objects are limited at each level. If you think about it, if you're moving down from level to level, you're moving through half the tree, but that's not necessarily half the objects, because what if all the objects are just in your little section there? So you're not really necessarily avoiding half the objects, but you're going through half the space, but not necessarily half the objects. So half the evidence, it's false. And you've got other questions here. And for using trees to store collections, it talks about something here that's pretty obvious, but most of the tree data structures discussed in the books, they're going to serve to store a collection of values. There's different types of trees out there for storing information. They're structured in ways where some are faster for searching, inserting, and removing the values. So you want to choose what type for doing what. So anyway, that is it for understanding the applications of trees. This is a short section. We'll be going into more information on binary trees in the next video, so stay tuned and we'll have that coming up soon. Aloha.